Good morning, students. Today we will discuss about 3D production pipeline. 3D production pipeline is divided into 7 steps. Step 1 is modeling, then step 2 is texturing, step 3 lighting, step 4 rigging, step 5 animation, step 6 particle and dynamic, step 7 is rendering. Now we will talk about 3D modeling. 3D modeling or three-dimensional modeling is the process of developing a mathematical representation of any three-dimensional surface of an object, either inanimate or living, via specialized software. The product is called a 3D model. It can be displayed as a two-dimensional image through a process called 3D rendering or used in a computer simulation of physical phenomena. The model can also be physically created using 3D printing devices. Models may be created automatically or manually. The manual modeling process of preparing geometric data for 3D computer graphic is similar to plastic art such as sculpting. 3D modeling software is a class of 3D software used to produce 3D models. Individual programs of this class are called modeling applications or modelers. Now we will talk about texturing. Texturing is a method for defining high frequency detail, surface texture or color information on a computer generated graphic or 3D model. Texture mapping originally referred to a method now more accurately called diffuse mapping that simply wrapped and mapped pixels from a texture to a 3D surface. In recent decades, the advent of multi-pass rendering and complex mapping, such as bump map, normal map, displacement map, reflection map, specular map, occlusion map, and many other variations on the technique controlled by a materials system have made it possible to simulate near photorealism in real time by vastly reducing the number of polygons and lighting calculations needed to construct a realistic and functional 3D scene. Now we will talk about lighting. Lighting refers to the simulation of light in computer graphics. This simulation can either be extremely accurate, as is the case in an application like radiance, which attempts to track the energy flow of light interacting with materials using radiosity computational techniques. Alternatively, the simulation can simply be inspired by physics, as is the case with non-photorealistic rendering. In both cases, a shading model is used to describe how surfaces respond to light. Between these two extremes, there are many different rendering approaches which can be employed to achieve almost any desired visual results. Now we will talk about rigging. 3D rigging is the process of creating a skeleton for a 3D model so it can move. Most commonly, characters are rigged before they are animated. Because if a character model does not have a rig, they cannot be deformed and moved around. They are stuck in whichever pose the modeler decided to put them in. The rigging process can become very technical and seem overwhelming at times. But after a little practice, you will be creating great rigs number in no time. Animation. Now we will talk about animation. Animation is the process of making the illusion of motion and the illusion of change by means of the rapid display of a sequence of images that minimally differ from each other. The illusion, as in motion pictures in general, is through to rely on the phi phenomenon. Animators are artists who specialize in the creation of animation. Animation can be recorded with either analog media, a flipbook, motion picture films, videotape, digital media, including formats with animated GIF, flash animation, and digital video. To display animation, a digital camera, computer, or projector are used along with new technologies that are produced. Now we will talk about particle and dynamics. A particle system is a technique in game physics, motion graphics, and computer graphics that uses a large number of very small sprites, 3D models, or other graphic objects to simulate certain kinds of fuzzy phenomena which are otherwise very hard to reproduce with conventional rendering techniques, usually high chaotic system, natural phenomena, or processes caused by chemical reactions. Examples of such phenomena which are commonly replicated using particle systems include fire, explosions, smoke, moving water such as a waterfall, sparks, falling leaves, rock falls, clouds, fog, snow, dust, meteor tails, stars and galaxies, or abstract visual effects like glowing trails, magic spells, etc. These use particles that fade out quickly and are then re-emitted from the effect's source. Another technique can be used for things that contain many strands, such as fur, hair, and grass, involving rendering an entire particle's lifetime at once, which can then be drawn and manipulated as a single strand of the material in question. Particle system may be two-dimensional or three-dimensional. Now we will talk about the last step, which is rendering. Rendering is the final process of creating the actual 3D image or animation for the prepared scene. This can be compared to talk a photo or filming the scene after the setup is finished in real life. Several different and often specialized rendering methods have been developed. These range from the distinctly non-realistic wireframe rendering through polygon-based rendering to more advanced techniques such as scanline rendering, ray tracing, or radiosity. Rendering may take from fractions of a second to days for a single image or frame. In general, different methods are better suited for either photorealistic rendering or real-time rendering.